Okay, so what we'll be talking about today is graphing functions by using transformations. So to start off with this, let's zoom out a little bit so we see more of the paper. So we can then say the goal here is to perform transformations of functions by starting with their parent function. So what I mean by starting with the parent function is, if you remember, it was earlier on in this chapter where there are some basic functions that we said, hey, we should know, which is the most basic function. Like if you know what the graph of x squared looks like, that's the parent function, and then we can perform the appropriate transformations. So we're going to basically talk about transformations, which means moving things left or right, up, down, stretching, compressing, reflecting, and so on. So we're going to start off by talking about vertical shifts, which is when we move a graph up and down. So the vertical shifts of graphs. So let's kind of summarize it first. Now, and think about it this way. If we're shifting a graph up and down, if you think about it on a coordinate plane, if things move up and down, which values change, the x or the y values? Well, if you think about it, if I'm moving things up and down, it's only the y values. So you're going to notice how this is going to affect only the y values. So suppose c is a positive number, so c is greater than 0, then the graph of y equals to f of x plus c. Now notice how, what am I doing? I'm adding c to my y values because f of x is a y value. So what is this going to do? This shifts the graph of y equals to f of x upward c units. Okay, so then what if we say then the graph of y equals to f of x minus c shifts the graph of y equals f of x. So now if I'm subtracting c, and by the way, hopefully you see why it's important for c to be greater than 0, because then f of x minus c, this becomes, we're actually subtracting. So f of x is moved what? Downward. C units. Okay, so with that said, let's look at our first example where we'll put this to use. So for example 1, we'll say sketch each graph using transformations. So anytime, and by the way, anytime you're asked to use transformations when we're graphing, when we're using transformations, you have to pretty much start from the parent graph or the most basic graph. Okay, so with that said, we're going to start off with the first one, which is f of x equals to x squared minus 1. And then the second one is f of x equals to the square root of x plus 2. So if I start with, see, by looking at this, I know what the basic graph is, see, because of the x squared. So what I know is when I'm using transformation, I'm going to start with the most basic graph, which is f of x equals to x squared. And then, which we know what the graph of that looks like. If you remember, those are one of the parent functions that we talked about. So x squared is what? 0, 0, 1, 1, negative 1, 1. And the graph looks like this. Now the x squared minus 1, see what's the minus 1 saying? Is it's saying grab the graph of x squared and move it down 1 unit. So f of x equals to x squared minus 1. it's literally this guy, except we're grabbing all its points and we're moving them down 1 unit. Okay, and it will look like this. Okay, so that's our graph. So, and by the way, anytime you're asked to use transformations, you have to do this. You start from the basic function and then you transform it to what the new one is. So you might want to pause the video and do this on your own, but let's kind of start on this. So we know that the parent function that I want to start off with is what? It's rad x, because we know what the graph of radical x is. So rad x has a graph 0, 0, 1, 1, 4, 2. And then this plus 2 is saying what? Grab this graph and shift it up 2 units. So we'll be at 0, 2, 1, 3, and then 4, 4. I'm running out of room here, but this is kind of this graph just moved up 2. So it looks like it's increasing faster, but it should be this guy just moved up 2. So that's f of x equals to rad x plus 2. Okay, so with that said, now let's talk about our horizontal shifts, which we're moving graphs left and right. So of graphs. So we're going to say suppose c is greater than 0. So once again, we're going to talk about that. So then the graph of y equals to f of x minus c. So remember, so notice how we're moving things left and right. How come? Because now this c is attached with the x. So we're changing the x values, where earlier on, if I come back up here, we were saying f of x plus c. So notice how the plus c is outside, which is affecting the y value. So when you see that the c is paired with or grouped with the x, that's when we know we're moving things left and right. And for the x minus c, now we think backwards. We see, so where for the other one, when it was minus c, we're moving it down. This is going to mean we're moving it to the right rather than left. So this shifts the graph of y equals to f of x right c units. Okay, and then we would say the graph of y equals to f of x plus c shifts the graph of y equals f of x left c units. Okay, so that's, now that we have our horizontal shifts, let's look at a graph, or our next example where we'll be creating these transformations. So for example 2, we're going to say sketch each graph using transformations. Okay, so let's, and we're only going to have one to graph, which that's fine. X plus 2 cubed plus 2. Okay, now if you look at this, there's actually two transformations going on, right? See, this x plus 2, see, this is inside grouped with the x. This is saying I'm going to move my graph, what, 2 units to the left. And this plus 2 is on the outside, which is saying I'm going to move my graph 2 units up. So do you see how it's going, how this is working the way it does? And we're going to have to perform two transformations. Now, the order you choose to do them in, it doesn't matter. For transformations, horizontal or vertical, you can do them in any order. But what's the basic graph we're going to start off with? If you think about this, what's the main function we see? This is a cubic. So we're going to start off with x cubed, and we know what the graph of that looks like, which is literally just 0, 0, 1, 1, negative 1, negative 1. which we know x cubed looks like this. So now I'm going to choose to move this up 2 units first. So this would be f of x equals to x cubed plus 2. So this is saying just grab all the y values or all the points and move them up 2 units. So it'll be, instead of 0, 0, it'll be 0, 2. Instead of 1, 1, it'll be 1, 3. Instead of negative 1, it'll be negative 1, 1. All right, and my last transformation is what? It's move it 2 units to the left. So I'm going to continue from here, and I'm just going to move everything 2 units to the left. So that becomes f of x equals to x plus 2 cubed plus 2, which then, if I grab these points and move them 2 to the left, this 0, 2 will now be what? Negative 2, 2. Negative 1, 1 will now be negative 3, 1. And lastly, 1, 3 will be negative 1, 3. And there you have it. So that's our completion. Now remember, you have to do this when you're asked to graph something using transformations. If you're not asked to use transformations, then you can graph it however you want. But the best way to make sure that you don't make any mistakes is by using transformations. Okay, so the next thing is when we're reflecting graphs. Okay, so we're going to say the graph of y equals to negative f of x. Now let's look at what's happening here. What am I doing? I'm taking the opposite of the y values. So if you think about this graph, because of this negative, right? If I take the opposite of the y values, what am I reflecting with respect to? I'm reflecting with respect to the x-axis. So what we're going to say is this reflects the graph of y equals to f of x in the x-axis, right? So opposite y values means you're reflecting with respect to the x-axis. And then what if we have the graph of y equals to f of negative x? Now look at what I'm doing. I'm taking my opposite x values. So if I come here and I take the opposite x values, right, if this is x is negative 1, it'll put me here, then that means I'm reflecting with respect to the y-axis. So when you see f of negative x, that just means this reflects the graph of y equals f of x in the y-axis. Okay, so let's do an example where we'll do this also. So for example 3, we're going to say sketch each graph using transformations. So these are going to be a little tricky. So let's talk about this. So if I have f of x equals to 1 over negative x plus 3 minus 1. Okay, so if I want to graph this with reflections, so one comment I want to make is this. When you see a negative in front of the x, we know that there is a type of a reflection, okay? Except since it's negative x plus 3, I want to be careful about this since it has something extra with it. Whenever I see negative in front of the x, I always write it in factored form, and I'll show you why. So if I factor out a negative, look at how this looks. Okay, so why is this important? Because now if you look at this, this is actually saying what? We're rotating it, or we're not rotating it, we're shifting it horizontally 3 units to the right. Whereas if you leave it like that, you would think that we're shifting it 3 units to the left. But if we look at our notes, what we see is we need to have what? We need to have, to see if we're moving things left or right, we need x minus c. We don't need just, we can't have a negative x. It has to be just x minus c. Okay, so with that said, I want to make sure that this is x minus 3 so I could see my transformations. So this negative, since it's with the x, I could then say, what function am I starting off with first? F of x, which is 1 over x. I start off with 1 over x. How come? Because this is of the form 1 over x. And we know what the graph of 1 over x looks like. It's something like this. Okay, so then I could say, all right, now one other comment I want to make. I always leave transformations until the end. Okay, so as far as the vertical and horizontal transformation, so always do reflections first. Okay, that's going to help us from making mistakes in the long run. So always do reflections first. So if I do this negative x, what does that mean? Since the negatives with the x, I could say this means reflected about the y-axis. So if I'm reflecting this about the y-axis, where would that put me? It would put me here and here. Okay, so I just grabbed this and reflected both by the y-axis. So then what do I want to do? This minus 3 means move it 3 units to the right. So f of x equals to 1 over negative x minus 3, which then if I move everything 3 units to the right, now remember we had a vertical asymptote at 0, so if I move the vertical asymptote 3 units to the right, then the next point will be here, and then this one was at negative 1, 1 will be where at 2, 1 now, which looks like that. And then lastly, the minus 1 is saying what? Shift everything 1 unit down. And if you remember, we also had a horizontal asymptote at 0 because this graph just gets closer to 0. So if I move everything 1 unit down, that horizontal asymptote will be where? At negative 1. So at 3, so then this point is going to be where it'll, instead of being at 4, negative 1, it'll be at 4, negative 2. That side looks like that. I'm kind of running out of space again. This one, instead of it being at 2, 1, it'll now be where? At 2, 0, because I'm moving it down 1 unit. And there's your graph. So notice how I'm using transformations to go with about this. Okay, so that's where I want to stop today. We will continue the notes. So this is just part 1. And the next time the next section or the next half of this notes, we'll talk about vertically stretching and shrinking and horizontally stretching and shrinking these graphs. So you'll get the notes on that on the second half.